Okay, today we're going to introduce matrices, and I'm going to go over some of the operations that you use with the matrices. So just a couple terms I want to go through. A matrix is a rectangular arrangement of numbers, and each number is called an entry. So you guys will want to copy this information down. Dimensions for the matrix are listed as the rows by columns, and then I've got an example right here. This is just a matrix, an arrangement of numbers, and this is a 2 by 3 matrix because it's got 2 rows. Okay, these are the rows, and it's got 3 columns. 1, 2, 3. So it's a 2 by 3 matrix. Okay, we're going to go through finding the sum, difference, and a scalar product. So we're going to do a little bit of multiplication, but a later video we'll go over the full multiplication process. So go ahead and copy this down, matrix C, matrix D, and matrix E. So example 1, we're going to add C plus D. So it's just going to look like this. So I'm going to go ahead and write those down. So C plus D. Now, when you're adding and subtracting, the dimensions must be the same for each matrix. So for this example, we can check that, but I'm looking at a 3 by 2. Okay, so this is a 3 by 2 matrix. It's got 3 rows and 2 columns, and then D also has 3 rows and 2 columns. So we were able to add these. Now if the dimensions were different, you would not be able to add. And we're just going to take, I'm going to take the 2 entry and I'm going to add it to the same entry on D, which it would be the 5. So 2 plus 5, and then I'm going to get my answer matrix. It really doesn't matter what order you go in, but I'm going to go ahead and do -3 plus 8. And I'm going to pack and do 8 plus 0, and 1 plus 7, 10 plus -2, and -5 plus -4. And this is my solution. That's my sum. Okay, now we'll do D minus C. Okay, so I'm going to write it in that order. So matrix D minus matrix C. I know these two have the same dimensions. Now we're going to do the same thing, except we're going to subtract each entry that aligns. So for example, I'm going to do 5 minus 2. answer matrix. So 5 minus 2, that's going to be 3. 0 minus 8 is going to be negative 8. And negative 2 minus 10 is going to be negative 12. And I'm going to do it for the second column. 8 minus a negative 3 is actually 8 plus 3, which is 11. 7 minus 1, which is 6. And negative 4 minus a negative 5, so that would be negative 4 plus 5, which is 1. And that would be my answer matrix. Okay, now we're going to do something called scalar multiplication. Which is the easier, I would say, part to multiplying matrices. I want to be able to see matrix E because I'm going to use that for one of my examples. So we'll do a couple more. So let's do 3E. Okay, so it'll look just like that. So that means they want us to take matrix E and multiply it by 3. So it'll look kind of like this initially. So with scalar multiplication, you're going to just multiply each entry in that matrix by 3. So you're just going to triple everything, and that will give you your answer matrix. So I just did 3 times 6 is 18, 3 times 4 is 12, 3 times 9 is 27, etc. And that gave me my answer matrix. So it really didn't matter what the dimensions were. On this one it was going to be a 3 by 3. But on scalar multiplication it doesn't matter. So let's do one last example. Do 5C. So I'm going to copy down my matrix. And then I'm going to multiply everything by 5.
Hey, Jim, it's me. I forgot to ask you, did my package for you get there yet? Give me a text and let me know, okay? Okay. Talk to you later. Bye.
And then, so I just multiplied 2, 8, and 10 by 5, and I'm going to do the same thing. And then that completes my answer matrix. So have a great day.